Hello and welcome. Myself, Mr. Bulake Bhavashok, Rayat Shikshan Samstha, Abasai Marathi Arts and New Commerce Science College, Rajapur District, Ratnagiri. This video is for education purpose only. No copyright infringement. This copyright belongs to its rightful owner. Credit goes to respective video music composers and singers. And please like and share my Rare Knowledge Bank YouTube channel. In this topic, the last lecture we have seen that the various types of mechanism are seen like AAC2 mechanism and BAC2 mechanism as well as the tetrahedral type of mechanism we have seen. Now we have discussed the new topics pericyclic reaction. In this topic, we have studied the various types of pericyclic reaction. The majority of organic reactions which involve the formation of ionic or free radical intermediates which then change into products. But however, some reaction can take place without forming any intermediate. Such type of reaction are also known as pericyclic reaction. So we have seen the definition of pericyclic reaction. The reaction are one step concerted reaction involving cyclic transition state without forming any intermediate is called as the pericyclic reaction. Now we are going to discuss the characteristics of these pericyclic reactions. The first characteristics are there, which they are reversible, involving ring closure and ring opening type of reaction. Means that in this reaction can be done the ring closing are there as well as ring opening type also there. Second characteristics are there. They are independent with solvent and catalyst. Means that we have seen number of reactions can be done with the help of the any one of the solvents like the polar solvents or non-polar solvents and the catalyst which can be helped to increase the rate of reactions. But pericyclic reactions which are independent of the solvent as well as catalyst. Next characteristics, bond breaking and making can take place simultaneously. Means that in such reactions it cannot be happen in the first step as a bond breaking, second step as a nucleophilic substitution, nucleophilic addition type of reaction. But in pericyclic reaction, such a process like bond breaking and as well as bond, the new bond is forming are take place simultaneously. Next characteristics, they can be initiated by the action of heat or light. Means that such a reaction can be take place with the help of only the heat energy or the light energy. Next characteristics, the pericyclic reactions are stereospecific. You know that stereospecific means that in thermal cis product in photolysis gives the trans product. This is called as stereospecific reaction. We have seen its thermal reaction, cis product, photo product, photolysis or photolite diffusion, only trans product as a major product. So reaction is a stereospecific. And next point we have going to the classification of pericyclic reaction. Pericyclic reactions are classified as the further subclassified, which are discussed in subsequently. For example, the first type is the electrocyclic reactions. Electrocyclic reactions are the reaction involving rearrangement of two or more pi bond systems. Next types are the cycloaddition type of reaction. In this type of reaction can involve addition of the 2 pi electrons system forming cyclic products. Third types, the sigmatropic rearrangement. In sigmatropic rearrangement can be involved the rearrangement of the sigma bonds. Next type is the cheletropic reaction. Such reactions can be involved the special group of cycloadditions type of reaction can be done. And last type is a group transfer reaction. This type of reaction are the special group of sigmatropic rearrangement can be done. These different type of pericyclic reaction are we have discussed one by one. Now the first type we have see the electrocyclic reaction. Electrocyclic reaction are the process in which the open chain compound with conjugated pi bonds is rearranged and to give a cyclic product or reverse of it is called as electrocyclic reactions or it is a ring opening type of reactions. Electrocyclic reactions are the one-step reaction taking place by the or action of heat or light involving formation of a cyclic nonpolar transition state. For example, this is some characteristics of this electrocyclic reaction. First characteristics are this. It is a one-step reaction involving a cyclic nonpolar transition state. The reaction is highly stereospecific. The reaction gives stereoisomer depend on whether reaction carried out thermally or photochemically. During this reaction, the products contains one pi bonds less than reactor. For example, such type of reaction are the electrocyclic reactions. For example, the 2,4-hexane undergo electrocyclic ring closure to give 3,4-dimethyl cyclobutane. For example, this butadiene 1, 2, 3, then 4. So butadiene 1 and 3 position having the double bond, therefore also named as 1,3-butadiene. Then what happens is simultaneous type of reaction means such bonds are attack on this carbon, and this carbon-carbon double bond like this are move is here, and to form such a type of cyclic non-polar transition state. And then after in this carbon-carbon double bond is formed and the ring closing type of reaction can be done. Similarly, this 1,3,5 hexatriene, which can be treated with this heat or the light energy. What happens? This bond is move is here, this bond move is here, and this bond move is here. Therefore, this is the new bond is making like this. This is a six-membered non-polar cyclic transition state. Then after what happens? The 1,3-cyclohexadiene, it is the final product. We have compared these reactants and products. What type of bond can be moving? See here, this carbon-carbon double bond is moves is here to form the carbon double bond. This is carbon double bond. This carbon-carbon double bond move is here. So this is a carbon-carbon double bond. It is single bond. And this carbon-carbon double bond move is here to form carbon-carbon single bond. So this is a single bond. So simultaneous bond breaking and making can take place in electrocyclic type of reaction. So electrocyclic reaction, what happens? Within molecules, within molecules, the bond can be breaking and making can take place. Another examples we have see that this is 2,4 hexadiene. So 1, 2, 3, 4, 5, and 6. Okay. 1, 2, 3, 4, 5, and 6. So 2 and 4 double bond. So 2,4 hexadiene. Two products are possible. Which one products? This is another atom is a hydrogen. It is also another atom is a hydrogen. Okay. So this hydrogen is and another hydrogen is this. So we have formation of the product is see here. The carbon carbon its bond is formed is here. 1 minute. So this is the new bond is formed between these two carbon, and this bond move is here to form the carbon carbon double bond. So this cyclobutane is formed. The one of the methyl group it will be above the plane, and one of the methyl group is below the plane. In last times we have seen that it is a stereospecific reactions because a thermal reaction it gives trans product. Here thermal reaction it gives trans product, and in photochemical reaction gives a cis product. Therefore electrocyclic reaction is stereospecific in reactions. Now we have seen the cycloaddition reaction. In cycloaddition reactions are the two pi bonds which are joining and to get the products. So what is mean by cycloaddition reaction? It is a reaction in which The unsaturated molecules. Unsaturated means carbon-carbon triple bond or carbon-carbon double bond. Unsaturated molecules in which the 2 pi electrons system undergo addition to give cyclic product involving cyclic transition state. So such a type of non-polar cyclic transition state are found in cycloaddition reaction may be either thermal or photochemical, but any other pericyclic reaction it involves concerted bond breaking and making resulting cyclic transition state. It is two types of cycloaddition reaction. The first is the 2 pi plus 2 pi cycloaddition reaction. 2 pi means this is a 2 pi cycloaddition and this is also 2 pi. 2 pi plus 2 pi cycloaddition reaction. In this cycloaddition reaction, the photochemical reaction between the two unsaturated molecules having a 2 pi electron system by action of UV light they add to each other. See here, the bond of this carbon-carbon double bond is attack on this, and this bond is attack on this carbon. So simultaneous bond breaking and making can be take place, forming a four-membered cyclic transition state. During this reaction, the two pi bonds are utilized and in forming two new sigma bonds. This is two pi bonds. This is one pi bonds. This is one pi bonds which are utilized and to form two sigma bond. This is one sigma bond and this is another sigma bond in the product. Since the reactant contains a 2 pi electron system and the reaction is called as the 2 pi plus 2 pi cycloaddition reaction. Why it is a 2 pi plus 2 pi cycloaddition? Because the 2 pi it is also 2 pi. So 2 pi plus 2 pi cycloaddition reaction to get the product having the two new sigma bond. This is one sigma bond and this is another sigma bond. Let's we are going to next type is 4 pi plus 2 pi cycloaddition reaction. In 4 pi plus 2 pi cycloaddition reaction, what happens? It is a thermal reaction between conjugated diene like 4 pi systems and another unsaturated molecules like 2 pi electron system. When they are heated with the unsaturated molecule adds to the ends of conjugated systems and a forming six-membered ring. During the reaction, the two pi bonds are utilized and to form two new sigma bonds. Since 4 pi electrons of the diene and 2 pi electrons of unsaturated compounds which are involved, therefore is called as the 4 pi plus 2 pi cycloaddition reaction. For examples, this 1,4-butadiene. So 1, 2, 3, 4. So 1,4-butadiene. So 4 pi. It is a 2 pi plus this 2 pi. So 4 pi and it is a 2 pi. So 4 pi plus 2 pi cycloaddition reaction in presence of heating conditions. What happens? It partially form bond between this and this. So new two sigma bonds are formed. This bond is attack on this carbon. This carbon-carbon double bond is transferred to this, and this carbon-carbon double bond transferred to this. So simultaneous bond breaking and making can be take place through their six-membered cyclic transition state. To get the new carbon-carbon double bond form is here. Another possibility is that these cis product are converted to the trans product. How will you convert this? This is a carbon-carbon double bond. It here is converted to trans. Now, very famous reactions we have see that the 4 pi plus 2 pi cycloaddition reaction, like Diels-Alder reaction. Diels-Alder reaction are another name as the 4 pi plus 2 cycloaddition reaction. Why it is a 4 pi plus 2 pi cycloaddition reaction? Because this is a 4 pi and this is a 2 pi reaction. So 4 pi plus 2 pi cycloaddition reaction, another name is Diels-Alder reaction. What is meant by Diels-Alder reaction? It is a reaction in which unsaturated compound called as a dienophile. This is a dienophile. Dienophiles adds to 1 4 position. This is a 1 position and 4 position. 1 and the 4 position. So 1 4 position of the conjugated diene. This is a diene cysteine. Name is a butadiene. Diene cysteine to form cyclohexane derivatives called adduct. It is called as 4 pi plus 2 pi cycloaddition reaction. See these examples. This butadiene and acrylonitrile. What happens? These carbon-carbon double bonds form this carbon. So new one of the sigma bonds are formed. This carbon-carbon double bond is transferred to this carbon, and this carbon-carbon double bond transferred to this double bond. Form the double bond is here and to get the adduct. Similarly, we have add this butadiene in presence of malic anhydride. In heating conditions, what happens? This carbon-carbon double bond is transferred to this. This carbon-carbon double bond form this carbon-carbon double bond is here, and this carbon-carbon double bond is transferred to this. So two new sigma bond are formed. One of the sigma bond is here, and one of the sigma bond is here. And to get this type of adduct.